All right, number 19, we have x over x minus 6 plus 12 over x plus 6 minus 72 over x squared minus 36. And again, we're dealing with rational expressions. So if you watch some of the previous videos where we had to find or build a common denominator, you know that I go ahead and stack all of the original fractions that we were given and that helps me to organize myself and build a common denominator. So I'm going to go ahead and do that again here. And again, so we started with x over x minus 6, and then we had 12 over x plus 6. Now you'll notice that here we had a plus in between these two fractions, didn't we? And so I don't have one here because this plus just indicates that we are going to have a positive 12x. So I don't write it, but some people like to write it. So you could do plus 12 over x plus 6 if you wanted to, if that helps you to stay organized. Nothing wrong with that. But here, since we have a minus, I'm going to do minus 72, right? Because if we take it and distribute that minus to what is a positive 72 in this numerator, it becomes a minus 72, right? And so I build the signs or the operation that we're performing into the sign of the numerator. But again, if you don't like doing that, whatever way you're most comfortable with, as long as you arrive at the same answer, it is all good. And that's a minus, x squared minus 36. All right, so again, we're building a common denominator. So let's go ahead and see what we've got. And we know that the first step in building a common denominator is actually factoring each denominator so we can see which factors we're going to be dealing with. And so in the case here of x over x minus 6, well, x minus 6 can't be broken down any further. And so x minus 6. And then we have 12 over x plus 6. Well, again here, the x plus 6 we cannot break down any further. And now we come to the last part, negative 72 over x squared minus 36. Well, here we can break this down, can't we, into x, not x squared, but x plus 6 and x minus 6. And we know that the common denominator is going to have one of each term that is unique, or one of each factor, I guess is probably a better way to say it, that is unique. So here we have an x minus 6, here we have an x plus 6, and here we have an x plus 6, x minus 6. And so this last denominator here has both factors in it already, right, from the original problem. And since there's no other factors that are unique, we're not dealing with any other factors besides this x plus 6, x minus 6, that's going to be our common denominator. So x plus 6, x minus 6. And since we already had both of these factors in this denominator, the last one here, the negative 72 over x squared minus 36, we're not going to have to change anything with this last fraction here because we already have that common denominator originally in the denominator. But here, in order to get from x plus 6 to our now common denominator, x plus 6, x minus 6, and let me go ahead and write the common denominator again up here. What did we have to multiply by? Well, we started with x plus 6, and we're trying to get to x plus 6, x minus 6. So what factor were we missing? Well, we were missing the x minus 6, weren't we? Well, whatever we have to multiply the bottom by, we also have to multiply the top by. And so now we end up with multiplying our numerator, in this case 12 times x, well that gives us 12x, and 12 minus 6, that's going to give us negative 72. Alright, and now let's see, to go from x minus 6, which was originally in this first fractions denominator, to the now common denominator, x plus 6, x minus 6, well, which factor again were we missing? Well, we were missing the x plus 6, weren't we? And again, whatever I multiply the bottom by, I have to multiply the top by, so x plus 6. So we have x times x, well that gives us x squared. X times 6 gives us plus 6x. And now we've built our common denominator, right? And we've multiplied all of our numerators by what we were missing. So our common denominator can just come on over. So x plus 6, x minus 6. And now let's go ahead and combine our numerators. And I didn't actually move this over yet, but minus 72, right? We didn't have to multiply this denominator by anything, so we don't multiply our numerator by anything. So that minus 72 just comes over. All right, so let's see what we have here. We have x squared, so x squared plus 6x plus 12x minus 72 minus 72. All right, so let's go ahead now and combine like terms from our numerator. So we have x squared, and I'll go ahead and guess we'll write up. So we have x squared, and now plus 6x plus 12x, well, that's plus 18x, minus 72, so minus 144, and now over the common denominator, x plus 6, x minus 6. And now what we can go ahead and do is factor this numerator into its two respective factors to see if we can cancel anything in the denominator. All right, and so we know that this is going to break down into two binomials over the common denominator, x plus 6, x minus 6. And again, no GCF here, and since the coefficient in front of our x squared is a 1, we can use the simplified version of either scissors or the AC method. So we're looking for factors of 144 that subtract to give us a positive 18. All right, well, again, we're going to break down that x into x and x, and I think we're going to be dealing with a plus 24 and a minus 6. Positive 24 minus 6 gives us a positive 18, and positive 24 times negative 6 gives us that negative 144. And now that we've factored the numerator, we can clearly see that the x minus 6 cancel, and so we are left with just x plus 24 over x plus 6. And that's our final answer. We performed the indicated operation, so we added and subtracted these three fractions and then expressed in lowest terms. So again, it's not that, stopping here is necessarily incorrect, except for the fact that our directions explicitly say to write the answer in lowest terms. Lowest terms meaning factor everything you can, and then if anything cancels, go ahead and cross it out, cancel it out, divide it out, and rewrite your answer with only the factors that are left. So would you get the same answer if you plugged in x to this expression and this expression? Yes. But this expression is in lowest form or lowest terms. All right, so there was number 19. Let's take a look at number 20.